Okay, welcome. So on to graphing rational functions. And in this one, what we're going to do is just kind of talk about how to graph a rational function. First talking about the reciprocal function down here. And then what we'll do is getting into rational functions that are going to have vertical asymptotes, horizontal asymptotes, slant asymptotes. And we'll also talk about identifying the X and Y intercepts. So we'll kind of go through a little bit. I might talk about a little bit domain and range here, but that's not really going to be a major topic here. We're just going to work through a lot of examples. Here we'll go through all the asymptotes, how to find them, and then you can see there's a lot of different examples that I really want to kind of focus on. I'm not really as much stressing as far as the graphing portion of it, but really how to identify all that information so therefore you can graph it, or at least understand the behavior of the graph, if that's something that you need to graph, or obviously if it's just something that you need to kind of understand. So to get started, I just want to kind of go back to the starting of something that we should all know before starting this, and that's just how to find the X and Y intercepts. Because when we're trying to find the X and Y intercepts of any function, we know that all we need to understand is that the X intercept, or let's do this, the Y intercept is when X is equal to 0. So all we're simply going to do here, is we're just going to plug 0 in for X and then solve for f of X. Now again, in this case, we're using f of X representing the output value, but just remember that that is interchangeable really with Y, okay? I'm going to replace this as Y so we can understand this in terms of X and Y's. Instead of a f of X axis, we'll just talk with at Y axis. So then I have 1 over 0 minus 1 plus 3. Well, 0 minus 1 is negative 1. 1 divided by negative 1 is going to be negative 1 plus 3, and therefore we can see the y-intercept is at y is equal to 2. Or you could write that as a coordinate point 0, 2. All right? Now to find the x-intercept, then that is going to be the x-intercept is when y is equal to 0. Okay? Or if you're thinking of this terms as like f of x, then that would be when f of x is equal to 0. So basically what we're going to do here is we're going to set f of x equal to 0, and now we're going to solve for x. So this one does take a little bit more algebra to do. We have to use the inverse operations, and we have x in the denominator, which we don't really like, right? It's a little bit extra steps. So the first thing I'm going to do, though, is I'm going to get to 3 to the other side, and then I have negative 3 is equal to 1 over x minus 1. Now to get the x minus 1 off the denominator, I'm going to multiply by an x minus 1 on both sides. Let's get that over a little bit farther. Okay, and then I'm going to distribute that, so therefore there'll be a negative 3x plus 3 is equal to 1. Now to save myself a little bit of work here, well, I'll just do it step by step. Then we can subtract the 3, and therefore now I have negative 3x is equal to a negative 2, and then divide by 2, or divide by 3, negative 3, I'm sorry. And then our final x-intercept is x is equal to a positive 2/3, which we can also write as a coordinate point 2/3, 0. Okay, so we're going to basically follow that same process here for g of x as well as in y. Now I'm just going to do it a little bit, not as much showing as much steps as this, and I won't, I'll just do the y-intercept. So therefore, I'll just replace this with a y. That's going to be 3 over 0 plus 2 minus 2. So therefore, y is equal to 3/2 minus 2. Now here, to get these to be common denominators, I'm going to put this over 1. Actually, I'll put it over 1 like this, and then I'll multiply by 2 over 2. Therefore, I get y is equal to 3 minus 2 times 2 is 4, so 3 minus 1 is going to be a negative 1 over 2. So y equals negative 1/2. And then to find the x-intercept, I'll just go ahead and put a 0 here, and therefore I have 3 over x plus 2 minus 2. So then put the 2 and then multiply. So therefore, I'd have a 2x plus 4 is equal to 3. Subtract the 4, subtract the 4. Well, let's not show my steps. Subtract 4 on both sides, you'd have a 2x is equal to a negative 1, and then x is equal to a negative 1/2. So interesting here right? You can see that they both share the same, but again, they're different coordinate points, right? Don't get them confused. That's a 0, negative 1/2. And this is a negative 1/2, comma 0. Okay, and again, I'm just using my techniques. I added a 2, and then I multiplied by the 2 plus x plus 2 on both sides, and then distributed that, and that's how I got that value, and then went from there. Now this one, if I want to find the x-intercept, I'm going to put a 0 in for y. Now this one kind of creates something interesting. I have a negative 2 over 5 times 0. Well, 5 times 0 is 0. You can't have that in the denominator. So therefore, there is no x-intercept. Why I keep on wanting to write x-intercept like that. And then when I do the y-intercept, keep on doing it again, I put 0 is equal to negative 2 over 5x. And again, to get the x off the denominator, I'm going to multiply by a 5x on both sides. And again, I get an equation that doesn't make any sense. I get 0 is equal to negative 2, which is not true. So therefore, guess what? There's no y-intercept here. So that can happen when we're dealing with rational equations and we're graphing them, that you're going to, it's possible that you're not going to have a y-intercept, you're not going to have an x-intercept. We can deal with, a lot of times you're going to see fractions in this section. And sometimes things are going to work out rather easily, all right? And so typically, things work out rather easily when we're dealing with the reciprocal function. And the reciprocal function is the parent here, is f of x equals 1 over x. And there's a couple different variations of this. Oops, I forgot to change this. That's supposed to be an h. So basically, you know, if we have 1 over x, if we just have a horizontal and vertical transformation, if you remember from our functions unit, you know, h is shifting the graph left or right, k is shifting the graph up or down. And then you can deal with a and b. Now I did a here in this case because if we just multiplied by like a times 1 over x minus h plus k, remember, a represents your vertical stretch or compression. So even though a is technically being multiplied outside the function, a lot of times if it's just a 1 or anything up top, you know, we're just putting it up there in the front. So a lot of times you're going to see it in this form, but therefore you understand that that value can really be brought out in front and it represents the a. Well, remember, b is being multiplied by the x inside the function. And remember, we usually typically want to factor this b out outside of the x, so we can see what exactly your b is as well as your h. And just remember that your h is shifting the graph left or right, k is up and down, a is vertical stretch and compress, and b is going to be your horizontal transformation. So these are all examples of reciprocal functions. You know, just to remember, another kind of key thing to remember here is f of x, you know, when you have a fraction, like for instance, you know, negative 4 divided by 2 is equal to 4 over negative 2, which is equal to a negative 4/2. And I bring this up because if I have something like a negative 1 over x, well, you could say, oh, well, that means a is negative, right? So that's a reflection about the x-axis. Well, that's the same thing as 1 over negative x, which means b is negative. That means it's a reflection of the y-axis, and which is the same thing as a negative 1 over x, where you can't tell, is it a or is it b? And the reason why is it doesn't matter if it's a reflection about the x-axis or the y-axis, because this is an odd function. And if you remember what this function looks like, the reciprocal function, just is a nice little hyperbola here. And the important thing to also remember, so you can see here, this parent graph does not have any x and y intercepts. It does have a vertical asymptote at x is equal to 0 and a horizontal asymptote at y is equal to 0. So this graph approaches, that's supposed to be straight, these vertical and horizontal asymptotes. So there's the parent function, important things to kind of remember. So therefore, obviously, if we're going to be shifting the graph left or right, you're going to be shifting the asymptotes as well. And that's important when we get into the graphing portion. However, the stretching and compression is not going to affect, as far as like the movement of them, except obviously when you have a b, which can mess things up. But we'll talk about that. So let's go ahead and get into some functions here. So in this case, you can basically see that this is my reciprocal function. You know, I could also write this as same thing as 3 times 1 over x. right? So you can the only thing that's really happening here is my A is 3. That means the graph is basically just being vertically stretched. But I still have my horizontal and vertical asymptotes. So it says graph the function and identify the X and the Y intercepts and the vertical and horizontal asymptotes. So since this graph is not shifting left or right or up and down, then I'm going to have the same asymptotes. Okay, and the only thing that's happening from here to here is just like a vertical stretch. So I'm not going to be perfect on my vertical stretch. I'm not really trying to be. Obviously, if you can create a table of values to help you with how this graph would be stretched or compressed, you can kind of see like what exactly those values would give you. But again, that's not really my main concern here as far as getting the graph, perfectly correct. However, I did provide a link here though that we can go ahead and take a look at. Oops. So let's go and bring that link over here so we can see it. And therefore, you can see this graph, and so not too bad, right? I mean, roughly close enough. And now obviously we have here, we can see that there are no X and Y intercepts. So just read this, the X intercept, none. Y-intercept, none. And the reason why there's no X and Y intercept is because you can see the vertical asymptotes were not changed. The vertical asymptote is at X equals 0. So if there's a vertical asymptote at X equals 0, obviously there's going to be no X or Y intercept. And if there's a horizontal asymptote at Y is equal to 0, then there's not going to be an X intercepts. So, wait. At X is equal vertical asymptote, horizontal, and Y equals 0. Yeah, okay. And that's it. Cool. All right. So in this next one, you can see that I obviously have an H and I have a K. So therefore, what I'm going to do is I'm just going to label my transformations. Remember that H is shifting your graph left or right, and K is shifting your graph up or down. So again, this is kind of a review from our functions unit. So I guess I can go back and label them. A couple things, I just didn't really write this. So let's see, horizontal or so. So I remember we already did this. I'm going to move on. All right. So therefore, this is going to be shifting. So we'll just say left 2 units. Remember, the reason why it's left 2 units is because this is X opposite of H. So again, I could write this as X opposite of -2, right? Because X minus -2 is really the same thing as X plus 2. So you can see that the H is actually -2. That's why it's going to the left. And we're going down 1. Okay. Now, when graphing this, basically I'm going to do is I'm going to redraw this, but obviously I have my new asymptote. I have an asymptote that instead of being a vertical asymptote, instead of being at 0, is now 2 units to the left. So at -2, I'm going to draw a nice little vertical asymptote. And then instead of having a horizontal asymptote at 0, I'm going down 1. So a horizontal asymptote is going to be at -1. Okay. And now I can go ahead and just sketch the graph. And again, it's going to be very similar to the parent graph. There's no stretching or compression. Looks good. All right. Now we can see here, though, by doing this, I gained an X-intercept and a Y-intercept. So when I do my math, I'm going to want to make sure that I've identified at least an X and a Y-intercept. So this is going to be just like the warm-up that we covered. Let's go ahead and cover the vertical asymptotes here. So the vertical asymptote is now at X equals -2. The horizontal asymptote is now at Y is equal to -1. And let's figure out this X-intercept. So X-intercept is when Y is equal to 0. So that's going to be 1 over X plus 2 minus 1. So that would be X plus 2 is equal to 1. X is equal to -1. Again, I'm kind of slowing down the work, and the reason why is because I went through this step by step over here. So if you're kind of wondering how I'm getting to this answer, I'm basically following this same process. It's basically what I did as I distributed. Okay, so I added the 1 multiplied by X plus 1 on the same side, and then I subtracted it. Therefore, so I can say the X-intercept is -1, 0. And then to find the Y-intercept, I'm just going to plug 0 in for 1. So I'll have y is equal to 1 over 0 plus 2 minus 1. Y is equal to 1/2 minus 1. Well, you could get common denominators if you need to, but 1/2 minus 1 is going to be y equals negative 1/2. And again, does this make sense? Does it make sense for my y-intercept to be at -1 and this to be at negative 1/2? Yeah, that kind of looks pretty, not too bad, right? I did a pretty okay job. So I'll say my y-intercept is at 0, negative 1/2. All right, now let's get to the next one. Ooh, whoa. This does not look like anything that we've been doing because, so I have this number in front of this, and then I have a b, but it's not factored out. So, okay. All right, so this one's gonna take some work. So what we're gonna wanna do is we're gonna wanna make sure we put this into our format, okay? First thing, instead of k being in front, we can put the k in the back. That's not a big deal. But the main important thing is b. We gotta factor this b out. All right, now I decided to do something where b cannot be factored evenly out, meaning it's going to create a fraction. So I decided to have some fun with you guys here. So I can factor out a 2. That's going to give me an x minus. Now, when you basically factoring out is like dividing out. So therefore, this is going to be a 1/2. Now, again, how am I sure? Well, remember, you can always check your work by factoring by multiplying it back out. 2 times x is 2x. 2 times negative 1/2 is negative 1. All right. And then this is 3. This is a positive 3. So I'm just going to put that right there. All right. Now we got to graph this. And you can see that my horizontal asymptote. So let's see. Let's write down what's happened here. This graph now has a, let's see, it's a horizontal compression of 2. We are going to the right 1/2, and we're going up 3. All right, so let's go up to 3. So what I'm going to do is I'm going to redraw my asymptotes. So I'm going up 3, so I have a horizontal asymptote. Instead of it being at 0, or y equals 0, it's not y equals 3. My vertical asymptote is at, here's 1, so 1/2 would be right there. Okay. So again, just to kind of give you a rough sketch here, I don't want to get too crazy. Let's see here, my X Intercept. Well, I don't even know what that would. Negative times 2. Oh, let's just draw a rough sketch. Actually, let's figure it out, and then we'll draw it from there. So before I even sketch, I'm going to actually figure out what these X and Y intercepts are. Now, I can figure out my, so my vertical asymptote is at x is equal to 1/2, and my horizontal asymptote is at y is equal to 3. Okay, and again, just to recall, why is this being, remember it's x minus h, right? So it's x minus h. So you can see that h is going to be positive 1/2, right? And that's why it's being shifted to the right 1/2. All right, so let's go and find these x and y intercepts here and find the x and y intercepts to kind of make sense of where this graph is. So the x intercept is when y is equal to 0. So 0 is equal to 3 plus 1 over 2x minus 1. So I'm going to subtract the negative 3 over there. So I have negative 3 equals 1 over 2x minus 1. Now I'll show my work here. I don't know why, but I will. So to get this off the bottom, I'm going to multiply by 2x minus 1 on both sides. Make sure to distribute the negative 3. So therefore, I have a negative 6x plus 3 is equal to 1. Subtract the 3. So now I have a negative 6x is equal to a negative 2. Divide by negative 6, divide by negative 6. 6 reduces down to a positive 1/3. That doesn't seem right. Oh, that'd be 1/2. So yeah, that's 1/2. So 1/3 is going to be like right there. So I'll just stay right there. And then to find the y-intercept, we're just going to do y is equal to 3 over 2 times 0 minus 1. Oh, that's a 1. Oops. Let's just erase that. That's going to be 3 plus 1 over 2 times 0 minus 1. Okay, so 2 minus 0 is 0. 1 divided by negative is 0. 0 minus negative 0 minus 1 is negative 1. 1 divided by negative 1 is negative 1. So therefore I have y equals 3 minus 1. Y is equal to 2. So let's write these out. So my x-intercept is going to be 1/3 comma 0. And my y-intercept is going to be at 0 comma 2. So there's my y-intercept, there's my x-intercept. So now I'm going to kind of sketch a graph here. It's going to look something like that. This one's not going to cross the x and y-intercept there, but you can see we already have those 2 points. And again, let's just double check our work here on that one, because that's, oops, there we go. So this last one that I did here, let's see, that was this one. There, that one, good job. And then let's go down to this one here. Again, like Desmos, because you can check 1/3, 0, 2. Good job, right? And again, this is all stuff you guys can go ahead and check on your own. And now let's just go ahead and do the last one. And the last one, something again that's not in our correct form, right? So the basic thing that I like to do in this case is let's write it in this correct. We want to have it's x minus h, right? So let's rewrite this as 2 over negative x plus 3. But again, you can see we have another b. We have a coefficient of x, so it has to be factored out. So that's a 2 over a negative x minus 3. Now again, this negative can be in the denominator, it can be in the numerator, it can be in front. Either way, it doesn't really matter. It's a reflection of the x-axis or a reflection of the y-axis. Doesn't really matter, right? It's either one. If you reflect x-axis or y-axis, you're going to get the exact same graph. So all we know is we have this reflection. Now that I have factored out the negative, I can see that I am shifting this, because I could also write this as 2 divided by negative x minus 3. Right? So my h is 3, so that means I'm going to go to the right 3 units. But I'm not shifting my graph up or down at all. So therefore my horizontal asymptote is still at y is equal to 0. My vertical asymptote, though, now is at x is equal to 3. So I'm going to go to 3, draw a nice little asymptote here. My horizontal asymptote at y equals 0. Draw something like that right there. I do have a vertical stretch of 2, which is going to impact the graph, but I'm not going to be too worried about it. Rather than drawing my hyperbola here and here, I know they're going to be over in this case, right? Now, again, since I have a horizontal asymptote at 0, I know that I have no x-intercept. So I'm not even going to do the math because I don't need to. X-intercept does not exist, so there's none. So let's figure out the y-intercept so we can try to do a nice little parabola. So to identify the y-intercept, all I got to do is plug 0 in for x. So y is equal to 2 over 3 minus 0. Y is equal to 2/3. So the y-intercept, so that's going to be a little bit less than 1. So that'd be over there. And again, just remember that I'm just replacing my function notation using the y. Okay, so here we go. We'll just go ahead and draw this graph looking somewhere like that. And looking like there. So there you go is your 2 graphs here. And now let's go ahead and work into reciprocal functions when they are not the same.